Hi, and welcome to my presentation on my master's project. In this presentation, I will introduce the project with some context and discuss achievements, highlight key findings, go over contributions, impact, and potential future work. So this project started back in semester two, where a research question was formed through a series of lab tasks. I chose to explore how augmented reality can enhance self-directed learning for university students. Given that study habits and education changes over time, and students and lecturers have to adapt and face new challenges. The core research question, how can augmented reality be utilized by university students for enhancing self-directed learning, positions this project as a speculative and qualitative exploration. Through user research and desk research, it aims to examine how both students and lecturers perceive the potential of AR in educational contexts and where or how it might realistically support more effective study habits. Throughout semester two, a portion of user research and desk research was done by interviewing undergraduate students and writing an annotated bibliography and literature review. And throughout semester three, I gained insights from interviewing students and lecturers from different areas of study, conducting remote A/B testing, using traditional study content like common PDF versus the same content in AR for round one of testing, followed by user testing to gain insights into the UX changes that were made to the AR prototype for round two. Desk research continued throughout semester three in a form of an annotated bibliography and case studies, just reviewing case studies and papers. To test AR against traditional study experiences, I chose a topic that's both familiar but also requires some specialized knowledge. So, like you see there, the anatomy of the human heart. It was presented across different prototypes, so like the static PDF, which is in line with traditional study habits, so just graphic and some text. And the same information was presented as a 3D model in as like an augmented reality prototype using a just using a participants' phones with an AR preview app. So key findings. From student interviews, a few clear themes came out. Most students rely heavily on digital tools like YouTube, creative tools, and AI, but still depend on lab notes, labs in general, and peer feedback. A big challenge is the lack of visuals. They often have to rely on imagination to bridge gaps in understanding, which can be confusing, especially under time pressure. When asked about AR, students saw strong potential simulating lab safety, visualizing abstract concepts like coding or circuits, and making complex systems more accessible. Importantly, they don't see AR replacing traditional study methods, but instead they are open to it if it integrates smoothly into their existing habits, with customizations and clear visuals being key. From lecturer interviews, a few key themes stood out. When it came to study habits, undergraduates often rely heavily on lecture notes and online resources, while postgraduates tend to be more self-directed and independent in how they approach learning. Uh, Lecturers noted that resistance to new tools is quite common unless there's solid evidence of their value in practice. And looking at the potential of AR, lecturers saw the opportunity in helping students visualize abstract concepts such as code or IoT systems or business data. They also pointed out that AR could be used to create immersive experiences like exhibits or even virtual site visits, which could add a lot of richness to learning. Importantly, AR also has strong potential to improve accessibility, especially when combined with mobile devices or other existing technologies like AI. In order, in terms of design and implementation, the message was clear. AR should be introduced gradually rather than all at once, so students and staff have time to adapt. And accessibility, remote usability, and clear guidance are going to be essential for adoption. And as one lecturer put it, AR in education still lacks its killer app moment, the big breakthrough use case that makes it indispensable. For A/B testing and user testing, the testing revealed four main themes. First, AR was consistently described as more engaging and immersive than static formats, giving a closer to reality feel. However, participants noted it works best alongside traditional study habits like note taking and reading. Second, usability improved between rounds. In the first round, users struggled with rotating and scaling the model, but in the second round, with the addition of on-screen prompts with a dismiss option, made the experience much more intuitive and gave users a strong sense of control. Third, mobile delivery was praised for accessibility, especially for self-directed learning, though the um, the onboarding process, scanning codes, downloading the app, and tracking the surface wasn't always seamless, and participants suggested a clearer feedback during the setup to reduce friction. And finally, both rounds showed a strong preference for hybrid learning. Static resources help with memorization and structure, while AR enhances visualization and spatial understanding, suggesting the combination may be the most effective for independent study. So, contributions and impact. So, this project contributes early insights into how AR can enhance university students' self directed learning. By conducting interviews with both students and lecturers and by running A/B tests and user tests with students, I was able to identify what makes AR engaging, where it falls short, and what design principles can guide future tools. One practical impact is drafting design guidelines that have started to emerge, such as mobile first accessibility, clear interaction controls, AR combined with traditional study habits, and visual anchoring and scaffolding. Um, these are lightweight but actionable takeaways that can influence how AR is prototyped for education going forward. Beyond academic value, the project shows AR's potential to support safe lab simulations, visual explanations of complex concepts, and flexible learning environments. This has real life um, implications for universities looking to innovate with limited budgets and for students who want more autonomy in their study. While small in scale, the findings create a foundation for future research and can inform educators, designers, and even edtech companies exploring AR in higher education. And looking ahead, there are several opportunities to build on this project. The current study focused on small scale qualitative insights to explore how AR can support self directed learning. Future research could expand in three directions. First, testing with larger and more diverse participant groups would provide stronger evidence and help identify differences across disciplines. Second, more advanced prototyping could integrate features like adaptive feedback, scaffolding, or multimodal learning support, moving closer to a full framework for AR in education. And finally, longitudinal studies would be valuable rather than just testing short interactions. Researchers could examine how sustained use of AI tools impact learning outcomes, motivations, and adoption over time. And this project lays some of the groundwork by showing what works and what doesn't in small controlled settings. Future work can be scaled up. Future work can scale this up, refine it, and ultimately test AR's place in university education more rigorously. And this concludes my presentation, and thank you for listening.